AC RC circuit. So a series AC RC circuit is an electric circuit composed of resistors and capacitors driven by an AC voltage or current source. So this is how an AC circuit looks like. So we have a voltage source, a resistor, and a capacitor. So this is the phasor diagram of an RC circuit. So since the phase angle of the voltage of the resistor is 0 and the voltage of the capacitor lags by 90 degrees, we can now get the total voltage by using the Pythagorean theorem. So V sub t squared is equal to V sub c squared plus V sub r squared. And getting the square root of both sides, we get V sub t is equal to square root of V sub c squared plus V sub r squared. So from the phasor diagram, by using the formula from the phasor diagram, V sub t squared is equal to V sub c squared plus V sub r c squared, where the V sub t is equal to I sub t z, V sub c is equal to I sub t x sub c, and the V sub r is equal to I sub t r. We can now substitute these values to this formula. So I sub t z squared is equal to I sub t x sub c squared plus I sub t r squared. And by dividing both equations by I sub t squared, we can get z squared is equal to x sub c squared plus r squared. And getting the square root of both sides, we can get the z is equal to square root of r squared plus x sub c squared. Impedance triangle. So the impedance triangle is the graphical representation of the resistance, reactance, or in this case the capacitive reactance, and impedance. So in the impedance triangle, we can get 4 information. 2 of these information have already been derived a while ago. So the third information is the finding the phase angle theta is equal to the inverse tangent of the capacitive reactance over the resistor, or equal to the inverse cosine of R over Z. But this information will be discussed on the power analysis part. And the fourth information is that the current leads the voltage by theta. So this is because when we remember the formula for the current, for the Ohm's law, I equals V over Z, and for the impedance, Z is equal to R minus J X sub C. When we substitute the value for the Z in the Ohm's law, we can get that I is equal to V over R minus J X sub C. And when we transfer this, the Z at the bottom, the sign will become positive. So in that way, we can conclude that the I leads the voltage by an angle. These are the summary or formulas that can be used for an RC circuit. So most of these formulas are either familiar to you or were derived by me or in the other discussions. So it's important to take note that the complex impedance is equal to R plus 1 over J omega C, or it can be simplified by Z is equal to R minus J X sub C. And it is important to take note that in an RC circuit, only the resistor absorbs power. So given these formulas, we can now go straight to the examples. So for problem number 1, a series circuit consists of a 66.2 microfarad capacitor and a variable resistor. For what value of resistance will the power taken be 172.8 watts if the impressed 60 Hz is 120 volts? So first of all, this is the circuit for our given problem. So this is our RC circuit because there's a given resistor, there's a resistor and a capacitor, and it is connected in series. So RC circuit. So we need to find first the capacitive reactance. So since the capacitive reactance is equal to 1 over omega C, or 1 over 2 pi f C. So plugging in the given values, we get 1 over 2 pi 60 and for the capacitance, and these values equal to 40.068 ohms. So from this power equation, P is equal to I squared R, we can now find the resistance. However, we need to substitute a few formulas in order to get the final equation. So first, this equation, P is equal to I squared R. We need to substitute the value of I equals VZ. So I squared R is now equal to V over Z squared R. And then from this formula, we need to substitute the Z squared into this formula. So Z squared is equal to R squared plus X sub C squared, and then we need to substitute the Z squared in this formula in order to resolve P is equal to V squared R over the value of Z squared, which is R squared plus X sub C squared. The derived equation P is equal to V squared R over R squared plus X sub C squared. We can now get the value for R. This is by substituting the values for P, the voltage, and the capacitive reactance. So the power is given 172.8. The voltage is 120. R over R squared plus the value for the capacitive reactance we have just solved, 40.068 ohms squared. So the final is 172.8 is equal to 120 squared R over R squared plus 40.068 squared. So since this equation is a quadratic equation, we should get the positive value for the answer. And to get the answer, we just can plug these values in the calculator to solve for R. So after plugging the values in the calculator, we get the value for the resistance R is equal to 30 ohms. So in this circuit, the value for the R is 30 ohms. Number 2. A series RC circuit is connected to a 230 volt 60 cycle source. If the power taken by the circuit is 4.8 kilowatts and the voltage drop across the resistor is 115 volts, calculate A, the current, B, the circuit impedance, C, ohmic value of the resistor, D, the capacitance of the capacitor, and E, equation for the voltage. So first, find the current or calculate the current. So we have a value for the power. So we will use the formula P is equal to IV. Manipulating, we get I is equal to P over V. So, and then substituting the values for P, power, and the voltage. The given power is 4.8 kilowatts or 4,800 watts divided by 115 volts.
Start.
So 4,800 over 115 is equal to 41.7 amperes. So A, the current is equal to 41.7 amperes. Find or calculate the circuit impedance. So in this time, I will use the formula I is equal to V Z, where we need to find the impedance. So manipulating, we get Z is equal to V over I. And by simply substituting and we have found the value for the current earlier, which is 41.7. So 230 divided by 41.7 is equal to 5.51 ohms. So for letter C is to calculate the ohmic value of the resistor. So for letter C, we need to find the resistance. So R is equal to V sub R over I. So we just need to substitute the value of V sub R and the answer that we've got earlier on. So equals the V sub R is equal to 115 volts. 115 over the current 41.7 and divided by 41.7 is equal to 2.75 ohms. We need to calculate capacitance of the capacitor. So we need to use the formula z squared is equal to r squared plus x sub c squared. So we need to find a capacitance, but we need to find first the capacitive reactance x sub c. Manipulating this formula, we get x sub c squared is equal to c squared minus r squared. So squaring both sides, we get x sub c equal to the square root of z squared minus r squared. So using this equation, we can now get the value for x sub c. X sub c is equal to the square root. The value of impedance that we got earlier is 5.51 squared minus the value of r 2.75 squared, and plotting or by inputting these values in the calculator, we get that the value of x sub c is 4.77 ohms. So after getting the value for the x sub c, which is 4.77 ohms, we can now get the value for the capacitance using the formula x sub c is equal to 1 over omega c. So since x sub c is equal to 1 over omega c, and we need to find the capacitance by manipulating the formula, we get c is equal to 1 over omega x sub c. So using the formula c is equal to 1 over omega x sub c, we can now get the value for capacitance. C is equal to 1 over 2 pi f, and x sub c, which we have got earlier, the value is 4.77 ohms. Multiply 4.77, and we cannot get C, and by inputting the values in the calculator, we get that the capacitance is 555 microfarad. So for letter E, we are asked to calculate the equation of the voltage V. So the equation for the voltage is V sub max sine omega t. But since we don't know the value of the V sub max yet, we use the formula VRMS is equal to V sub m, or V sub max over square root of 2. And by manipulating this equation, we get that V sub m is equal to VRMS square root of 2. And then substitute the
value for V sub max in this equation to get V is equal to V RMS square root of 2 sine the omega t. Omega t is equal to 2 pi f. So by substituting so VRMS is assumed to be 230 volts. So sine two pi times 60. F is equal to 60. And by calculating this equation, we get 325 sine 377